Today we are going to study the effect of source resistance in common source amplifier circuit. To find out the effect of source resistance, we are taking two common source amplifier circuit, one amplifier circuit which is having source resistance and another amplifier common source amplifier circuits which do not have source resistance. Let's study first a common source amplifier circuit which do not has source resistance. So in this circuit you can see that the source terminal is directly connected to ground. There is no source resistance connected. So the equivalent circuit of this will looks like that. Now the ID current will pass through this RD and that will pass through the transistor. The gate terminal of this transistor is separated by dielectric material from source and drain, so no current will pass through this branch, so Ig is 0. So Vg of the gate potential will become the supply VTH. Now VTH is nothing but the potential drop across this R2, that is R2 by R1 plus R2 into VDD. Now with the variation of temperature, resistance value varies. Depending on resistance value, this potential drop across this R2 will vary. So our potential drop across this R2 may increase or decrease, so that the VTH will increase or decrease. That means the gate potential will increase or decrease. Now the potential drop between gate and source is VGS equals to VG minus VS. So Vg equals to Vth and the source terminal is connected to ground, so Vs equals to 0. So Vgs equals to Vth. Now due to the resistance change or variation of resistance, if Vgs increase or decrease, that depends on Vth. So Vth increase or decreases, accordingly Vgs will increase or decrease. So if Vgs increase or decrease, then Id also will increase or decrease. So you can see that due to the increase of Vg, the Vgs will increase, so that the drain current will increase. Also the transconductance also dependent on the Vgs. So varying Vgs, the transconductance also varies. If Vgs increases, then transconductance also increases. Now in this circuit we have seen, if the gate potential increases, then the drain current and the transconductance increases. In this circuit there is no source resistors. Now let's have a look the common source amplifier circuit which has a source resistor Rs. Now if I simplify this circuit, will look like this circuit. So this ID current will pass through RD and Rs, and we know there is no gate current, so I is equals to 0. So Vg equals to Vth and Vth equals to R2 by R1 plus R2 into Vd. Now with the increase of resistance or decrease of resistance, the Vg will increase or decrease. So Vth and Vg is temperature dependent. We have already discussed that. Vgs equals to Vg minus Vs. Id also dependent on Vgs, and in this circuit you can see that there is a Rs which is connected to source terminal. So Vs is the potential drop across this Rs. So Vs equals to Id into Rs. Now Vgs equals to Vg minus Vs. So Vgs equals to Vth minus Id Rs. Now if Id increases, then Vs will increase. So if Vs increases, the Vgs will decrease because the Vg will not change and Vs will increase. So the potential drop between VGS will decrease. Let's take one example. Suppose due to the temperature variation, if the gate potential Vg increases, and then what will happen? The Vg minus Vgs will increase due to the increase of gate potential. Now, if Vgs increases, then the ID will increase because ID dependent on the VGS. From this equation, we can explain that if VGS increases, then ID will increase. Now, if ID increases, then what will happen? The drop across these RS, the potential drop across this RS will increase. So VS will increase. If VS increases, then Vg minus Vs will reduce down. So if Vs increases, Vgs will decrease. Now if Vgs decreases, then what will happen? The current ID will decrease down, so that the variation of drain current will minimize. And also same way we know that transconductance also dependent on VGS. Now as the variation of VGS is reduced by this RS, so the variation of transconductance also reduces. So what we can conclude here, these RS source resistance giving a negative feedback, and this due to this negative feedback the variation in the VGS decreases down, so that the variation in drain current decreases down and the transconductance variation decreases down, so that this feedback of this RS, presence of this RS giving a negative feedback, due to that this circuit become more stable, and with the change of temperature the bias point or biasing point of this circuit will not vary significantly. So that's the effect of this RS. Thank you.